1 gigabyte RAM. This is where modern computing technically starts and immediately struggles. Looking at a 1 gigabyte stick next to a 128 gigabyte stick tells the whole story. One looks almost empty. The other is packed with memory chips. And just like the hardware, the experience gap between them is massive. Back in the early smartphone and budget PC days, 1 gigabyte RAM was considered usable. Apps were lighter, websites were simpler, and nobody expected their device to multitask without freezing. Open one app, use it, close it. That was the lifestyle. In real life, 1 gigabyte RAM can barely handle a modern operating system today. Android, Windows, or even lightweight Linux systems will boot. Sure, but the moment you open a browser, things slow down fast. Switching between apps feels like time travel, and not in a good way. Forget gaming, heavy browsing, or streaming. Even basic tasks can feel painful. You'll mostly find 1 gigabyte RAM now in old phones, outdated tablets, smart TVs, car infotainment systems, or tiny embedded devices that only do one job. For normal users, it's effectively obsolete. And here's the important part. RAM isn't about numbers or technical stick configurations. It's about whether your device keeps up with what you actually do. If you browse the web, use social apps, stream video, or multitask at all, 1 gigabyte simply can't keep up anymore. 2 gigabyte RAM. After 1 gigabyte, 2 gigabyte RAM felt like a step up for a little while. This tier became common in PCs and laptops around the late 2000s and early 2010s. It showed up in budget netbooks, early Chromebooks, and low-end Windows laptops. Machines like the Asus E PC, early Acer Aspire models, and even some first-generation MacBook Airs came with 2 gigabytes of RAM. Back then, it seemed generous, but today it feels like trying to run a marathon in slippers. With 2 gigabyte RAM, you could handle extremely basic tasks, word processing, light spreadsheet work, or browsing a single website. Open a browser with more than one tab though, and your computer started struggling like it just woke up from a nap. You'd see programs freeze, fans spin like tiny jet engines, and your system would spend more time thinking than actually doing anything. Multitasking was basically a dream. It also marked the rise of lightweight operating systems like Chrome OS and Linux distributions optimized for low RAM. These systems could squeeze something usable out of 2 gigabytes, whereas Windows Vista or early Windows 7 machines would constantly hit the memory wall. This is when users realized RAM wasn't just a number. It directly impacted everyday usability. Today, 2 gigabyte RAM is mostly for emergency backup machines or super lightweight setups. It can barely run one modern browser tab smoothly, let alone multiple apps at once. 4 gigabyte RAM. 4 gigabyte RAM became the standard for budget laptops and desktops around 2010 to 2015. Back then, it felt like magic. Machines like the HP Pavilion, Dell Inspiron, early MacBook Airs, and mid-range ThinkPads came with 4 gigabytes as the sweet spot. Suddenly, you could actually browse the web without your computer immediately threatening to explode. With 4 gigabytes, you could comfortably open 3 to 5 browser tabs, write documents, check email, and even stream a YouTube video without everything freezing. Multitasking still had its limits. Try running Photoshop while Spotify and a dozen tabs were open and your computer might cough, sneeze, or straight up crash. But for everyday users, it was enough. This was also the era when Windows 7 and 8 became widely used, and 4 gigabyte RAM was officially the minimum you need to feel modern. It was ideal for students, office workers, and older relatives who just wanted to check email or browse Facebook without constant frustration. No gaming, no heavy editing, no thrill-seeking digital multitasking, but it did the basics well. And compared to 2 gigabyte RAM machines, it felt like going from a tricycle to a bicycle with gears. Even today, 4 gigabytes is still usable for very light tasks, budget Chromebooks, or ultra-basic Windows PCs. But opening more than a handful of tabs or modern apps will remind you that your computer is running on fumes. So basically, 4 gigabyte RAM is enough to get things done, not enough to get carried away. 8 gigabyte RAM. Around 2015, 8 gigabyte RAM became the updated standard for most new PCs, laptops, and even some mid-range Macs. This was the point where computers stopped feeling like fragile little boxes and started feeling like actual machines you could rely on. Machines like the Dell XPS 13, MacBook Pro, and budget gaming rigs all came with 8 gigabytes as the baseline. Suddenly, multitasking wasn't a crime. Your computer could actually handle it. With 8 GB RAM, you could open 10 to 15 browser tabs, stream music or video, run Office apps, and maybe even edit photos in Lightroom without the system gasping for breath. Light gaming? Sure, modern games ran on lower settings, and even some medium settings were playable. Video calls and streaming became smooth, and most everyday tasks just worked. This was also the era when casual gamers and students finally felt free. No more apologizing to your computer for overloading it. It became the baseline for home offices, students with multitasking needs, and content creators starting out without taking a loan from the bank. Of course, 8 GB isn't invincible. Heavier games or professional video editing might still cause stutters, and running huge files in Photoshop or Premiere could push it to its limits. But for the majority of users, it hit the perfect balance: fast, affordable, and reliable. Quick question: how much RAM does your current PC or laptop have? Drop it in the comments. And if you're finally understanding what all these RAM numbers actually mean, hit the like button. It genuinely helps the channel. 16 GB RAM. By around 2018, 16 GB RAM became the sweet spot. And in 2025, it still is for most people who actually expect their computer to keep up. If you're watching this video trying to decide what to buy, this is probably your answer. Mid-range gaming laptops, MacBook Pros, and custom desktops started shipping with it as standard, and suddenly multitasking didn't feel like juggling flaming swords. With 16 GB, you could play modern games on high settings without your PC wheezing, edit 1080p videos while Photoshop had a dozen layers open, keep Spotify blasting in the background, and juggle 20+ Chrome tabs, all without begging your machine to hang in there. Even streaming Netflix while downloading a game didn't make it sweat. Power users, casual streamers, and hobbyist content creators finally felt like their computers were on their side instead of sabotaging them. It's also the tier where switching between apps feels instant, not like you're running everything through a potato. Sure, heavy 4K video projects, massive Photoshop files, or running multiple virtual machines might still push it. But for almost everyone else, it's smooth, snappy, and future-proof for a few years. 32 GB RAM. 32 GB RAM showed up just as multitasking became a full-time job for power users. You stop checking Task Manager. You stop wondering which app to close first. You just use the PC. This tier started becoming popular in the early 2020s, especially as content creation, streaming, and heavier games became normal. Back when 4 GB was good enough and 8 GB felt high-end, suggesting 32 GB would get you laughed out of the computer store. Now it quietly makes sense. And in a few years, we'll probably say the same thing about 64 GB. With 32 GB, you can game on high or ultra settings while Discord, Spotify, Chrome, and recording software all run in the background without drama. Video editors can work on 4K timelines without previews turning into a slideshow. Large Photoshop files open without that awkward pause where you wonder if the app froze. It also brings back memories of how things used to be. Opening too many browser tabs once meant instant lag and fans screaming for mercy. Alt-tabbing felt risky. On 32 GB, multitasking feels boringly smooth, which is exactly the point. For basic users, this is still more than necessary. But for creators, developers, and heavy multitaskers, 32 GB is where the PC stops pushing back and starts keeping up. 64 GB RAM. 64 GB RAM exists for people whose projects are measured in gigabytes, not megabytes. This isn't about opening more browser tabs or getting 5 extra FPS in a game. This is the territory of serious workstations and people who push their machines all day. At this level, you're dealing with things like 8K video timelines, massive 3D scenes that take minutes just to load, multiple virtual machines running side by side, and huge datasets that would instantly choke smaller systems. Simulation work, heavy compiling, data analysis. This is where 64 GB stops sounding ridiculous and starts feeling necessary. The biggest difference isn't speed, it's stability. Projects don't slow down when they get complex. Apps don't crash the moment you layer effects or duplicate assets. You can render, encode, simulate, and research at the same time without your system begging for mercy. This is the kind of RAM setup you'll find in professional studios, research labs, enterprise development environments, and with extreme power users who treat their PC like a full-time tool, not a hobby. For everyone else, it's overkill. For the people who need it, there's no going back. 128 GB RAM. 128GB RAM exists for workloads that simply cannot fit into memory on normal systems. This isn't an upgrade you buy because something feels a little slow. This is something you buy because your workload would literally not run otherwise. At this level, you're looking at scientific simulations, massive databases, full server virtualization, Hollywood-grade VFX pipelines, and AI or machine learning models that eat memory for breakfast. This is the kind of RAM that lets you load entire scenes, datasets, or models into memory without constant swapping or crashes. For normal tasks, 128GB does absolutely nothing extra. Your browser won't feel faster. Your games won't magically look better. Your PC won't boot in half a second. For 99% of users, this much RAM is pure overkill and mostly exists as a flex. But in data centers, research labs, AAA game studios, and enterprise servers, 128GB makes sense. When time equals money and crashes are unacceptable, throwing massive memory at the problem is the safest move. If you're considering 128GB and you don't already know why you need it, you probably don't. And that's every RAM size explained. From ancient 1GB sticks that couldn't even open a browser, all the way to monster 128GB setups that make servers blush. Remember, more RAM doesn't automatically make your PC better. It's about matching your memory to what you actually do. Now here's the thing. You just learned how much RAM you need, but do you know which type to actually buy? DDR3, DDR4, DDR5? If those sound like random letters instead of real specs, you're not alone. And here's what nobody tells you. Buy the wrong DDR generation and your motherboard won't even recognize it. That's exactly what we're covering next. Every DDR RAM generation explained simply. Click the video on screen right now, and I'll see you there.